Graph of rational functions. This one is your test problem. So what I have done here is given you the function and also given you the answer. Have a good look at that. Okay. The part over here more important for me is for you to learn how to sketch these kinds of graphs, right? Now here, consider the function f of x equals to x cubed plus 3x squared minus 4x plus 2 divided by x squared minus 2. Determine the equation of all the asymptotes and explain the behavior of the function near its asymptotes, right? Now those of you who get this whole graph perfect and those of you who don't get it, take this as the answer for the first part, but from here explain the behavior of the function near the asymptotes. At least do the next part yourself, okay? So that's why I've given you the solution here. It helps, right? Now once you have the solution, it is always easy to sketch it also, correct? So it helps both ways. Now, how will you find oblique asymptote? That is the first question. How will you find oblique asymptote? Well, easy part first, we can always find the vertical asymptotes, right? So first part, let's do easy things always first, right? So say now, we have vertical asymptote, and vertical asymptote is when denominator is 0. That means x squared minus 2 equals to 0, and that means x is equals to plus and minus square root of 2, right? Perfect. So we know there are two vertical asymptotes, and in this case these are dotted lines which are going at plus and minus square root 2. Okay, so these are your vertical asymptotes, correct? Now second part is what you should do here is to find x and y intercepts, right? That's easy, right? So find f of 0. So f of 0 will give you y-intercept. If you plug in 0 here, you get 2 over minus 2, and that clearly gives you an answer of y-intercept is at x is equal to 0 and the y value is minus 1. So you see this minus 1 is your y-intercept kind of, okay? That's what we get here, right? Okay, now, so you get y-intercept. Now, the other thing which you want to know is the oblique asymptote. So how will you find oblique asymptote? That's the next question, to find oblique asymptote. To find oblique asymptote, do we have one? Yes, we do, because numerator degree is 1 higher than the denominator. There is no horizontal asymptote here, but there is one oblique asymptote since numerator degree is 1 more than denominator. To find oblique asymptote, you need to do long division, right? So do long division. Why am I doing it for you? I'm doing it for you because I don't want you to mess up. And well, try to do it, stop the video yourself. But here is kind of a hint for you. So this goes inside, which is x cubed plus 3x squared minus 4x plus 2, and you have to divide by x squared minus 2. You have to divide by x squared minus 2. Remember one thing, we have not written anything as a coefficient of x. It is important to write 0x here. That could be an error and that could make things very difficult for you. Now that is how you're going to divide it. So once you divide this by x squared minus 0x minus 2, you get your oblique asymptote. It's not a difficult process. Let's do it. So we can multiply by x here, right? If you multiply by x, you get x cubed and minus 0x squared, right? I'm purposely writing because it helps. It helps. Minus 2x, right? And then when you take this out, you get 3x squared. And that gives you minus 2x, right, plus 2. And to take care of 3x squared, we will do plus 3 here, right, 3 times. 3 times this will give me 3x squared minus 0x and minus 6. And that will give me, when you do this, here we'll get minus of 2x. And here we are going to get plus 8. So that is what you get, right? Therefore, the oblique asymptote for us is, now you can tell me what oblique asymptote is, right? The quotient is your oblique asymptote, and say y equals to x plus 3 is my oblique asymptote. And this line, which is shown here, represents oblique asymptote for you, correct? So that is oblique asymptote. Let me write now y equals to x plus 3, correct? And these are my two vertical asymptotes, correct, which are x equals to minus square root 2 and x equals to plus square root 2, correct? So that becomes our vertical asymptotes, right? Now, another thing important here is behavior near the oblique asymptote. Now let's look into that part. So let me write down the division statement now. So we have got f of x equals to x cubed plus 3x squared minus 4x plus 2 divided by x squared minus 2, right? So let me write this function here as f of x equals to, so we got x plus 3, do you see that? X plus 3 in the numerator, right? So we got x plus 3, and here we have plus, let me write plus here, and we'll write this as minus 2x plus 8 over x squared minus 2, x squared minus 2. So that becomes the remainder part, right? So that is their oblique asymptote, x plus 3, which is represented by this line. Now to find the behavior, end behavior, if x is very large, put x as 1000, this denominator is going to be positive, but numerator is going to be negative. Do you see that? Minus 2x. That makes us negative. That means our function value is slightly less than the line. So we are approaching from lower side. Do you see that? Approaching from lower side. Do you see that part? So that is the end behavior which you have to explain. And that is how you explain it, right? Now imagine that we have x as a very large negative quantity. Let's say minus 1000. Then minus 1000 times minus 2 is positive. So the function is slightly more than the line. So you are approaching from top. Do you see that? Above the line. So that is the kind of explanation which we are looking forward from you for this question, right? Well, all of the things you can definitely do, right? Now, my suggestion is that redo your question, right? And plot a neat and beautiful graph which is similar to what I've already given here as an answer for you. So copy this. F of x equals to x cubed plus 3x squared minus 4x plus 2 divided by x squared minus 2. Find the equation of your asymptotes and explain its behavior. And then you can write down domain, range, intercepts, and all of the discontinuities. Okay? Thank you.